Lesson 11.3, use normal distribution. All right, here we go. So now we're going to go to our standard deviation and why we have that and what that means. In life and with what we have found when you're studying probability, one type of probability distribution is simply called normal distribution. And this can be represented by a normal bell curve. And what they've done is they've taken, and this is where the whole sigma came from. So remember I said this, the sigma shows, the standard deviation shows how the numbers are clumped together. What they've done is they've taken this distribution curve and they've shown that if you place the mean in the middle, so the average of whatever set of data you have is in the middle, you want most of your data to be within this part, within one standard deviation away, either positive or negative, from your mean. All right, so you've got 68% of your data is within one deviation. If you go outward one more, and I didn't add up the numbers, if you go out one more standard deviation, that should include 95% of your data. If you go out one more standard deviation, that should include 99.7% of your data should be within 3 standard deviations plus or minus your average, your mean. All right, and now you don't necessarily have to understand how to come up with all of that. What I want you to do today is just understand how to use the curve. Okay, so let me show you what that means for you. All right, so these symbols, remember this is the sigma, and if you can't see it or understand it, because you know my drawing is lovely and that is these are not sixes, these are sigmas. So this means that from here to here is minus 1 standard deviation. And this is minus 2 standard deviations, minus 3 standard deviations, and this is your average. Now this is plus 1 standard deviation, plus 2, and plus 3. So we're getting away from the average by those standard deviations. Okay, so here's what a problem may look like, and let's just do some, and then I'll show you where the numbers are coming from. If we want to know what is the probability that a number lies between 1 standard deviation to the negative and 3 standard deviations to the positive. So anyway, yeah. So if you want to read it, what is the probability that that x bar minus 1 standard deviation is less than x is less than or equal to x bar plus 3 standard deviations. All right, what that means is you want to look at your graph and you want to be between negative 1 standard deviation and positive 3 standard deviations. So here's your curve, here's your mean, the average. This is 1 standard deviation to the left, that's 1 negative, and 3 standard deviations to the right is right here. So the probability that something is in between here or is in this section of the graph is 34%. The probability that something is in this section is 34%. The probability that something is in this section is 13.5%. In this one is 2.35, and anything to the right of 3 standard deviations is going to be just 0.15%. So what you need to do is this. You need to say, okay, so from here to here, this section, if something falls within this section, that has a 0.34 possibility or probability. If it's on this side of the mean within 1 standard deviation, then it has a 0.34%. Or not 0.34%, well, 0.34 probability, 34%. So we want to go all the way, if it's within this category, 2 standard deviations to the right, there's another 13.5, oops, 0.135, we're adding decimals. And then we want to go all the way to this line where it's 3 deviations. So we're going to add 0.0235. So then we simply add up all of those. So we want to know, what is the probability that it's between that? Well, it's all of these probabilities added up. So when we add all of that up together, we get 0.8385. And that's it. All right, so it's a lot of confusingness for not really much difficulty. Okay, so now what we might do, let's see, I think I switched these. Yes, okay, so here's what's going to happen. Now let's put some real numbers to it, and I don't know if I'm going to be able to shift it so we can see the bell curve at the same time. We'll have to make that work. Okay, so we have the score of an entrance exam are the scores that the people that took this exam were normally distributed with a mean of 200 and a standard deviation of 20 points. So we want to know two different things about what percent of the people that took that test scored lower than 160 points. And in order to pass the test, in order to be admitted into the program, you have to have at least 220 points. So we want to know about what percent of the people who take this test actually get permitted to be a part of this program. So here's what happens in this case. So now we have the mean is 200. So down here where it says, well, what is the mean? This actually has an amount now. This has a mean of 200. So what we could do is this, and honestly what I did in my notes, because I was like, how do I, okay, so I drew myself just a little graph, and I didn't draw the whole bell curve, but I drew a graph, and I gave myself this 200 is the mean. And then if the standard deviation is 20, that means each standard deviation is either plus or minus 20. So this then goes up 20, so that goes up to 220, and that goes up to 240, and we want to go 3 deviations away, so 1, 2, 3, so 260. And 3 deviations to the left is going to be 200 minus 20 is 180. Minus another 20 is 160, and we need to go 1, 2, 3 deviations, so that would be 160, 40, 30. No, 40. Ha ha ha. Oh boy, I didn't pass that test apparently. Okay, here we go. So now, and we've got to remember these percentages, but we can shift back and forth to get those. So now we want to know about what percent score lower than 160 points. So what we need to do is we need to go to that 160 point mark, and we need to see, okay, well, where on the bell curve is this? So this is our mean, and so 160 is 2 deviations, right? And then we want to know what percent score lower than that. So go on here, so on your curve. So here was our 200. So 2 deviations, that's where our 160 is. So anything less than that, there's either going to be a 2.35 or 0.15. So we've got, this is the 2.35 section percent, and that is 0.15% in this little section that I didn't leave room for. So for part A, what we're going to do is we're going to take this 2.35% that are in this deviation, and we're going to add it to this 0.15% that are in this deviation, and when we add that together, we find that what? 2.34, 2.4%, 4345. Whew. Thank you. You were hollering at me. I could hear you. Thank you. All right. 2.5% of the people who take this test actually score lower than 160 points. All right? So now for the second part, the same type of thing. We want to know, okay, so I've got to have 220 to be admitted. About what percent get in? Well, let's look to see. So 220 is where you've got to be admitted right here. And so we want to know what percent are accepted, well, that's anything above that. So what percent are accepted? What percent are above here? So let's see, the 200, oh dear. Okay, well, I think we have our question now, so we can move this so we can see our chart. So from here to here is the 34%. Oh, we don't even care about those, right? We want above that. So 13.5, 2.34, oh, 35, oh my goodness, I'll tell you what, and 0.15. So all of the ones above that are going to be in these three categories of the curve. So you would simply add the 13.5 plus 2.35 plus 0.14. And when you add that up, 13, 14, 15, 16%. So 16%, oh, that's not very good odds. 16% of the people who take that test actually get into this program. I think that in the original problem, they said it was a program for a firefighters, something. Okay, so that part is fairly simple. Now, what happens is, and I might have to read some of this to make sure I'm stating it right. Okay, so now the standard normal distribution, we take that information, and now the standard normal distribution curve is where the mean is 0. So instead of putting the mean where the 200 points or the whatever is in your problem where that mean is going to be. So if we're dealing with the standard normal distribution, we want the mean to be 0 and each standard deviation is just 1. All right? So in order to do that, we've got to have this cool, neat chart that is on page 759 of your book. And I didn't reproduce that for the board simply because it's tons of little bitty numbers. So please open your book to 759 so that you can look at that chart. What happens is this. You're going to need this Z value, this Z score. What you can do is you can use this Z score, take the number that you want to deal with minus your mean, minus your average, and divide it by the standard deviation, and that gives you a Z-score. Once you get that Z-score, you can use it to find the probability that something will occur within that standard deviation, or something that, if that item will occur, that data will occur simply by using the chart. So let's do one, and then I'll walk you through. So here's what's going to happen. And I'm going to move it over so we can see how to figure our Z-score. Oh man, and do we have it far enough over so you can see it? Oh no, low battery mode, quick. Did it stop? Oh, I hope you can, oh, we gotta go fast. Okay, there's a survey of 20 colleges, and in that survey, we found that the average credit card debt for seniors is $3,450. Woo, that's a lot of money. Debt was normally distributed with a standard deviation of 1,175. Find the probability that credit card debt was at most $3,600. Now, you could set up a cool bell curve, but then numbers and you know, whew. So let's use this cool Z-score, and we're going to say the Z-score is X minus the mean. Well, we know X is what we're trying to figure the probability of. So that's our 3,600. And we're going to subtract the mean. Well, the mean is the average, and we know that the average is 3,450. And we're going to divide by the standard deviation, and they tell us in the problem the standard deviation is 1175. So you've probably already done this on your calculator. 360 minus 3450 divided by 1175. Did you do it? Did you do it? Where is it? 0.12, I think. Roughly 0.12. Now what you're going to do with that, this is so simple. Once you've got, this is the hardest part, is finding the Z factor. Once you find that Z score, you're going to go to your book. And that book, that table is crazy, wild, confusing, but it's super easy. The whole numbers are along the left-hand side. The decimal part is to the right-hand side. So in our case, 0.12 has a whole number of 0. So you'd go down the left-hand side to the 0, and then across to 0.12 in this case is just 0.1 because we don't have, it rounds it to the nearest tenth. And when you go down to the 0 and across to the 0.1, you end up with 0.5398. 0.5398. And look and see where that is, because it's a positive 0.12. So go down to the positive 0, across to the 0.1, and you end up with 5398. And so the probability that the credit card debt was at most 3,600 is 53%, actually closer to 54%. And that's all there is to it. Use that chart. Huh? Pretty cool, huh? All right. After all that computing from the last couple of days, this will be a breeze. All right. See you next time.